So as we know that we studied before limiting friction. So what is the limiting friction formula? Anybody can tell? F limiting is equals to, what is the formula, guys? Mu s into n.
US.
Mu s into n. So what is mu s? Coefficient of what? Yes, please. Coefficient of
Yes, static friction.
Okay. So that is what? If the static friction become maximum, that is only called as what? Everybody. Static friction is maximum. That is what we used to call as something. What is that called? Everybody. Which we used to call
Limiting
as
friction.
limiting friction.
Limiting friction.
So always which friction is greater? Everybody. Always the maximum friction is out of all the types of frictions. Which friction is always maximum? Everybody. That is limiting friction only. Okay. Then yesterday's class, I taught you sliding friction. So sliding friction, what is another name, everybody? Sliding friction also we can call as yes, please. Dynamic friction, or we can say kinetic friction. So actually here, actually they are in motion. Means one surface is trying to sliding over the another surface. Then we is to called as it is sliding friction. During the motion, they are not in a tendency to move. When a body slides over a surface, means already they are in motion or not, everybody? Yes, please respond. Already they are in moving.
Yes,
means
sir.
one surface is already sliding over the another surface. Then we is to called as sliding friction. And as I told you, this sliding friction will represent with the Fk. That is what kinetic friction. So it's directly proportional to something. Anybody can tell what is that?
Normal reaction.
Normal reaction. So if you remove the proportionality and if you have taken equals to sign, so that is what? Static sliding friction or kinetic friction is equals to constant into normal reaction. So this constant only we used to call something. What is that called? Everybody. Called
Okay,
as
sir.
mu k into n. So what is mu k, everybody? Mu k means what? Fastly. Mu k
Coefficient.
coefficient of what friction?
Kinetic friction.
Yes. Coefficient of kinetic friction. Is it okay, everybody? Please respond. All of you? Yes. So till
Yes,
here
sir.
we studied that. Now you tell me which friction is less. Dynamic friction is less or limiting friction is less? Everybody.
Dynamic friction is less.
Dynamic friction. Note that word. Very important. Dynamic friction. Okay. Dynamic friction is less than the limiting friction. Limiting friction is maximum. What is that maximum friction, everybody? Static limiting friction. Understand, Mari? It is not limiting
Yes,
friction. It is static limiting.
limiting.
Okay. So because maximum static friction only we used to call what, guys? Maximum static friction only we used to call what?
Limiting friction.
Limiting friction. Okay. So always which friction is maximum? Everyone. Static, maximum static friction called as limiting friction. So this is what about sliding or dynamic or kinetic friction. Anybody have any doubt, you can ask me. So what is the kinetic friction formula, everybody? Kinetic friction is equals to mu k into n. So this is always depends on two factors. What is that depend? It will be depends on factors, everybody. It will be depends on, of course, it is remains constant. It is not variable. But who is variable? Who is variable?
Static friction
is not constant. Static friction is always variable. Understanding? And maximum static friction only we used to call as limiting friction. Now, this kinetic friction or sliding friction is depends on two factors which you studied yesterday also. Anybody, please? It is depends on what? Nature of the material. Yes, please.
Nature of the
Nature of
nature of the surface.
nature of the materials.
And body.
Materials of which the bodies are made. The bodies are made. And second one, everybody, nature of surfaces in contact. Nature of surfaces in contact. Do you understanding, everybody? So contact, what is the nature of surfaces means either rough surface or smooth surface or polished surface. That is the meaning of it. Okay, guys, everybody. Yes, please. What is the first point
Yes,
meaning? Nature of the material of which the bodies are made up of. For example, the body made with the plastic, the body made with the wood. So which is having more friction? Anybody can tell? Wood or plastic? We already studied yesterday.
Wood has more friction, sir.
Wood has more friction than plastic. This is what nature of the bodies which is made up of. Next, nature of surfaces means wood also maybe polished surface is there, and as well as what? Polished surface is there, and as well as another surface. What surface? Rough
Rough
surface.
surface.
Okay, so we cannot say anything. That is what. So that is what it will be depending. So if any same two surfaces are moving with a different velocity, do you think that sliding friction will change or kinetic friction will change? That is what is my question to you guys. All of you. Yes. If
The
the
question
body is
again.
traveling with the different velocities, even yesterday I have drawn you. Suppose you are traveling in your car, in your same road, the same road and the same tires always in contact. Now, do you think that the sliding friction, or you take it, you are having a toy car, or you are having some kind of a object which is like a rectangular one. Now you are dragging in a particular road. Understanding? So if you are dragging with a 10 meter per second or 100 meter per second, always the kinetic friction is remains what? Everybody
Same.
remains constant. Understanding?
Constant.
If they are the same surfaces, if the same surfaces are in contact, then always, irrespective of the speed, the kinetic friction is always remains constant. Everybody clear? Please respond. All of you? No response.
Yes, sir.
So
Yes,
again,
sir.
you will get these concepts in 11th, but there nobody will teach explanation and all. Only they will say rend formula. I'm seeing you can remember. They will say limiting friction is equals to mu s into n. They'll say kinetic friction is equals to mu k into n. Over that concept. They'll go for numericals directly. That is what you have to be well focused on concept. Ellame concept purima limiting everybody kinetic friction. Any doubt? Please let me know. All of you clear? Yes?
Yes, sir.
Now, we are
Yes,
going to
sir.
study the most important friction, that is what is called as rolling friction. So who is the least friction? Less than kinetic friction. Any friction is there? That is what we used to call as what? Everybody.
Rolling friction.
Rolling friction. So we will say rolling friction is the least friction, less than kinetic friction. If it is less than kinetic friction means what? Yes, please. If it is less than kinetic friction means automatically it is less than what friction? Because kinetic friction is less than static friction. So that what will happen, Ra? Rolling friction is also
It is
less
also it is lesser than kinetic
Yes.
friction.
friction.
than understanding. So everything it is. That is what you have to remember. So that's what first point you write it. What is the first point we'll write? Rolling friction is less than kinetic friction. Okay, and also is comma less than, what is that? Static friction also. Clear, everybody? So that is what you have to remember. Anybody having any doubt, you can ask me. Now, sir, when the rolling friction will come into the place, when it will come into the play means whenever any kind of object, all of you remember, it is the kind of frictional force which only come into the play when body rolls over the other. Do you understand it? It is not sliding over the other. It is rolling over the another. So how one object will roll over the another means they need something. What they need? What they need?
So
If one object wants to roll over the another, they need something. Anybody can tell? What they need? They need wheels or they need rollers. Am I right or wrong, everybody? For example,
Sir.
I have one big block. If you are trying to slide over the surface, you people need to apply more energy or less energy? Anybody? More energy or
More
less energy?
energy.
Yes.
Less energy.
But I will put a block of wood like a rollers. I will put a rollers and I will try to just imagining like a 3D picture. So I will put a rollers and I will put a above that I will put a wooden block. Now you people can easily push it or not? Everybody?
Yes, sir.
Yes, sir.
Yes, that is what. So whenever any object is sliding, suppose your car, imagine that your car wheels damage. Is it possible to go forward easily?
No, sir.
No. So if the wheels are there, then easily body can move. That is what. So it is always easier to roll a body over a surface than to drag it. Which is easy? Dragging. Dragging means sliding friction. Dragging means we used to call it as what? Sliding friction. So which is easy?
Sliding.
Rolling friction is rollers, wheels is easy or sliding is easy? Which is easy for you people? Yes, please. All of you.
Wheels.
Wheels. That is what it is called as rolling friction. I hope everybody clear. Understand, Amma? All of you? So please write.
Yes, sir.
So it is the frictional force when it will come into the play. All of you. Only it is the frictional force when it will come into the play, guys, which comes into play when one body rolling or sliding or
Rolling.
rolling. When a body rolls over the other. So rolling, it will possible only with the two. What is that? One is with the wheels, another one is with the what?
Rollers.
Rollers. Okay. So that is what you have to remember. So it is always easier to roll a body. Write it. Second point is over. Third point. It is always. My girls, are you understanding, Amma, everybody?
Yes, sir.
It is always
Yes, sir.
easier to roll a body. Easier to roll a body over a surface than what? Everyone, than to drag it.
Sliding friction.
Yeah, slide it or drag it. That is what you have to remember. Okay. So now, so we all know it is always less than kinetic friction and less than static friction also. So whenever you're talking about rolling friction,
Sir, what's that, sir? Than?
then
Surface.
than to drag it. Clear, Mari?
Yes, sir.
Yeah. So this rolling friction depends on two. One is all the vehicles, whatever running with the what? All the vehicles are provided with the what, guys? Everybody. Provided with what? Something.
Wheels.
Wheels. Okay. Next. Second one. How many of you are having bicycle? I think many of you are having bicycles and everybody having a good experience with the bicycle. Am I right? Everybody? Mr. Lingesh? Yes. So now if you notice it, sometimes your bicycle wheels can make sound like kar sound will come. By the time something is missing, you people will talk. Anybody can tell? Mr. Sanjay?
Grease.
Yes, something we used to call wheel will make sound when you are cycling. By the time you can say, if you go to the cycle repair shop, they'll say something is missing. What is that? Anybody?
Sir, grease is reduced over there. So reduced.
No. That is called something. Anybody can tell? There is a small goalie like things. We used to call that. Anybody? Yeah, somebody is
Sir, balls.
brake shoe knot. Yes. What is that? Kishore, brake shoe Lara. What is that? Anybody?
Sir, ball races.
It is exactly present in near to the axle. Near to the axle, they will be present. You might be notice it. Any other?
Chain.
No chain. Near to the axle. For a small like goalies, small balls like marbles, it is present. If they will
Ball races.
due to the friction, it will increases. What is that called as? Ball
races.
bearings. Everybody remember? Yes. Ball bearings. Teriyada?
Yes, sir.
Show you. Those who don't know, you can.
Yes, sir.
You can look into your bicycle, but it is covered with a metal. So just I will show you. Ball bearings in cycle. So you can put, you all can see that. You never seen, that's what your bicycle will start making sound if the ball bearings will lose. Have you checked it, everybody? Now everybody can remember. Have you seen? This is what we used to call as ball bearings. So here actually it will be present. They will lose means it will start producing the noise. Have you checked it, everybody? All of
Yes,
you?
sir.
Yeah. So here you can see that this is the bicycle axle. So there is a no contact between the axle and the wheel. So middle somebody is there. What is that called as? They are only called as ball bearings.
Ball.
If these ball bearings are lost or the ball bearings are rubbed, like friction, due to the friction, then it will start producing the sound. Kar sound will produce. Or normally you can see, this is the wheels. Have you noticed these bearings? I think many of you are having in your home. Am I right? Ball bearings. Yes, vehicles and all will use this one. So inside goalie, have you seen the small, like a spherical in shape? They are called as, we used to call as ball bearings. The small one, which we used to call as ball bearings. Okay, guys? Every vehicle, it has that. You can see here. These are only called as ball bearings. So these ball bearings will lose. Which one? The small spherical objects. If they will lose, then it will create more friction between the wheel and the axle. Yeah, it will make more sound. Okay. What is the first point, Lakshanya? Every vehicle has wheels. That's all. That is only the first point.
Okay, sir.
Understand? All the vehicles having wheels. You take any vehicle. Is there any vehicle without wheels?
No, sir.
That's all. That is only the first point. Yes, Kishore. Skating wheels also having the ball bearings. You can check it. Skating wheels will be there. Am I right? Many of you are having a skating students. So skating wheels also having the ball bearings. You can check it. This is what axle. Bicycle wheel, axle, and this side we can see that adjustable one. And here will be the ball bearings to reduce the friction and make your motion very easily. Next time, if you are having bicycle, you go outside after the class and you can check it. You can notice the ball bearings. It will be visible. Okay. So this ball bearings also example of what? Rolling friction or not? Everybody. Yes, please. All of you. Many missions will use this one.
Rolling.
So what is the reason? To minimize the friction or to maximize the friction? Anybody can tell? Ball bearings. What is the use, Amma? To minimize the friction or
To
maximize?
reduce the friction.
To minimize.
Yeah, to minimize to reduce, not Mari, to minimize the friction. Ball bearings are used in cycles and of course any vehicles. Many missions will use it. And mission parts, etc. To reduce what, guys? To minimize.
To minimize the friction.
To minimize friction. That is why we'll say rolling friction is the least friction. Is it okay, guys? All of you? Yes? Okay.
Sir.
Now,
Yeah.
so that again directly same. Rolling friction is also directly proportional to something. Anybody can tell? Like a kinetic friction. Rolling friction of a body is again directly proportional to something. Suppose if a body is rolling over the something, so we know that something is acting downwards. That is what? Weight. Weight is acting downwards. And upward, what is acting? Yes, please. Normal. Normal reaction. Remember, normal reaction we can represent either with a N or we can represent with what? R. Okay? That is what.
Sir, all the frictions are directly proportional to.
Yes, Mari.
No,
Rolling friction
no.
of a body is directly proportional to the whom, guys? Everybody? To the normal reaction. Okay? Normal reaction acting on the body. Okay, Ra, please respond, Ra, everyone. All of you?
Yes, sir.
From that I can say rolling friction it is. So I can take what? FR. FR means rolling friction is directly proportional to N. So mathematics, if you want to release the proportionality, what we have to do it? We have to take some constant. Clear, everybody? So the constant into N. So from that only I can say that constant rolling friction is equals to constant only. What we can say, guys? Anybody can tell?
Normal reaction.
Mu R
Yeah.
into N. Okay, everyone? Suppose if you want to find mu r, how to find Mari? Sanjay, mu r is equals to normal reaction will
Sir,
come.
F1 by N, sir.
Yes,
FL by
no.
N.
Rolling friction divided by r, divided by n.
Yes, sir, FR.
Okay, everybody? All of you understand, Emma?
Yes, sir.
Yes, please. So that is what
Yes,
you
sir.
have to remember it. Anybody having doubt, you can ask me. Again, same thing. This mu r, what is mu r? Anybody can tell? Mu r means what? Yes, please. Coefficient of
Rolling friction.
Coefficient of rolling friction.
yes, coefficient of rolling friction. Understand, Mr. Gokul Ras, Nivedan, Kishore? Coefficient of rolling friction. And this mu r depend on what? Anybody can tell? Again, same thing. Depends on not nature of the material it is made up of. Only say one thing. Depends on the nature of the surfaces. Depends on the nature of the surfaces in contact. Okay, Lingesh. Can you hear me, Lingesh?
Yes, sir.
Yeah, that is what it is. Okay, everybody, clear, Amma? All of you? So three
Can you
formulas
please wait?
now. So only one friction, there is no formula. For what friction, no formula, everybody?
Static friction.
Static
For
friction.
limiting
But
friction, there is
static,
formula.
maximum static friction we used to called as what? Maximum static friction we used to called as
Limiting friction.
limiting
Limiting
friction. So limiting
Limiting
friction
friction.
formula irka. Next, sliding. One object is sliding over the another. We are having sliding friction, or we can say kinetic friction. And then last one, any object is rolling over the second object surface, then there is a friction called as rolling friction. Everybody clear? All of you?
Yes, sir.
Girls, Agalya, Shivani, any doubt?
No, sir.
That new girl, understand new girl? What is her name? I forgot.
Yes, sir.
Yeah, any doubt you can ask me. Okay, Alfin, understand Alfin? Please report me. Now, there is a two important points. That is what note. All of you write it. Very, very important one. So I can say which friction is maximum. All of you, first one. Which friction is maximum?
Limiting friction.
Static limiting friction.
Limiting friction is greater than kinetic friction is greater than F. What is that? Rolling friction. F limiting means bracket I can say. What is that? F maximum what? Static friction. All of you clear? So then what is the coefficient? Which coefficient is bigger? Anybody can tell? That is what? Coefficient of static friction is greater than coefficient of kinetic friction is greater than coefficient of rolling friction. Okay, guys? Yes? All of you? Yeah.
Yes,
Now,
sir.
there is one more interesting point which I want to say. Of course, rolling friction is minimum compared to all other frictions. Will you all agree with me?
Yes, sir.
Yes. Now, all of you observe very carefully. For example, let me take, suppose two boys are driving with a car whose area of contact is very less. Means they are traveling with a tire who is having very less thickness. Understand? Less wider in nature. And there is a boy who is traveling in a JCB. Imagine that. Whose tires is greater wider. Means area of contact is more here compared to here. Am I right or wrong? Area of contact is where more?
Yes, sir.
Here area of contact is less. Area of contact is less. And here area of contact is more. Or else, how many of you know road roller? Road roller therima. Road roller also having wheels. Will you all agree with me?
Yes, sir.
Yes,
Yes,
sir.
but road
Yes,
roller
sir.
will go with 100 km/h. Road rollers.
No, sir.
No, sir.
No, sir.
Why? Anybody can tell? That is also having wheels only. Correct? Why?
Sir, more area, sir. So that
Yes, more area.
More
Correct.
mass.
More area of
More
contact.
mass.
Mass ille Gokul. More area of contact. Purima. More area of contact. Understand, Ra? Clear? More area of
Yes, sir.
contact.
Yes,
Rolling friction increases or decreases? Everybody. Rolling
decreases.
friction, of course it is least, less than all other frictions, but rolling friction also varies. How? Based upon the rolling friction increases. Increases with what? Increases with increase in
Yeah.
Increase in area of contact. Is it okay, guys? All of you? Please respond. Everybody? Suppose there is a lorry, we all people knows. When the lorry is traveling, have you noticed that if there is unloaded, some wheels are lifted away? Am I right, everybody?
Yes, sir.
Yes.
I know.
Yeah. But if it is loaded, all the wheels will be getting down. Am I right or wrong? Yes, tell
Yes,
me.
sir.
Of course, that is for balancing the pressure. But if the number of wheels are touching the ground increases, rolling friction increases or decreases? Number of wheels contacting the ground is increases. Rolling friction increases or decreases? That is what is my question to you all.
Increases.
Increases. Understanding? So area of contact increases, rolling friction also. Yes, please.
Increases.
That is what you have to remember. Any doubt in this, Mr. Nivedan, Mr. Pranavaswin, Princey?
Sir, rolling friction
No.
increases, sir, but the motion decreases.
Yes, yes. Speed will decrease, Mari. Clear?
Yes, sir.
Speed will decrease, but rolling friction increases. But still, that rolling friction is not greater than static friction or kind of sliding friction. Clear?
Yes, sir.
Hmm.
Sir, another one doubt, sir.
Yes, ask me. Somebody is asked.
Sir,
Wait.
in
1 minute,
sir,
Mari.
in rolling
Arasan
friction
is
and
asking
kinetic.
something. Mari, just a minute. Arasan is asking
Yes.
something. Sir, there is an object in one side, 55 newtons, is applied in another 100 newtons. The third force acting on the object would be frictional or gravitational force. Okay, one side 55 newtons and another side is 100 newtons. The third force acting on the object. Both frictional and as well as gravitational force, Arashni. Because whenever the surface are contact, so you are saying that exactly like this. For example, there is an object. So one side people are applying 55 Newton, another side it is applying 100 Newton. That is what you are saying. Am I right?
Yes, sir.
Yeah. Then there is
Sir,
a, of course, there is a frictional. Is it right? What is exactly you are asking?
sir, but the sir, Anthony sir told only frictional force would be there. There will be no gravitational force.
See, gravitational force always will acting. That is what W is equals to mg, but it is equals to what? It is equals to what?
Normal reaction.
Normal reaction. Understanding, Amma? So both are equal, but opposite direction. Opposite direction means both will get cancelled out. So we will consider this as a zero. Do you understanding? No displacement in upward and downward. Understand, Arashani?
Yes, sir.
Yeah. Actually, for 9th class, general NCERT level, we never talk about normal reaction. Have you heard about a normal reaction anywhere? You might be heard a word called as reaction exerted by ground. That is what balanced and unbalanced time you might be studied that. Okay. Clear, Amma? So whatever the body, always it will experience it normal reaction and weight. That is what gravitational force. But they will be equal and opposite so that it will be always balanced it. Clear, Amma?
Yes, sir. Thank you, sir.
So that is why we will consider only forward and backward. So there is a force, frictional force always. There is a normal force always, gravitational force also always. Keep it in mind always, any kind of object, any object is in a surface, always three forces will come into the play. That is, either object is in stationary, either object is in moving, doesn't matter. Always frictional force is existed. But if it is stationary, maybe it is static friction or limiting friction. If it is sliding, sliding friction. If it is rolling, rolling friction. That's all. Understand, everybody? But whatever it is, either object is in rest or object is in motion, doesn't matter. Always the pulling force is acting downward direction. What is that? Gravitational force. That is what? Weight of the object. Weight of the object is always act downwards and perpendicularly to that, opposite exactly. Weight opposite, what will act? What force will act? Normal reaction. Understand, Amma? So always they will be there. Okay. Yes, please. Next. So friction exerted by solids, we studied that. Now we are having
Sir,
friction.
doubt, sir.
Yes, Mari, ask.
Sir, in two quantities, sir, in frictional and kinetic. No, sir, in kinetic and rolling friction, you have said that constant into normal reaction. But in the limiting friction also you have said that constant into normal reaction, but it
Yes.
is variable, sir. how could it be?
Listen,
No.
Mari, limiting friction will never vary. Static friction will vary. That is why static friction, no formula. Do you understand?
Yes, sir.
That is maximum static friction only called as limiting friction. That you can find out.
Yes, sir.
But you cannot find, for example, Mari, I can apply this, suppose this vehicle I want to move. If I apply 100 Newton force above 100 Newton force, then only the body will start moving forward. Means then 100 Newtons is the F limiting. Clear?
Yes, sir.
Rolling friction, I can calculate it. If it is a rolling, I can find it rolling friction. If it is sliding, I can find sliding friction. That is what kinetic friction. But static friction means what? Maybe I am apply 1 Newton force, 2 Newton force, 50 Newton force. These all are C. It may be whatever it is. Everything is called as static friction. Do you understand it?
Yes, sir.
If I am applying 1 Newton force, keep it in mind, Amma. There is a very good question. If I am applying force less than limiting friction, if I am applying the force less than limiting friction, do you think that body will start moving, everybody? No. By the time, for example, see, I am having an object, I can move this object only if I apply the force greater than 10 Newtons. What is that, everybody? If applied force is greater than 10 Newtons, applied force is greater than 10 Newtons, then only body can move. Means what is the maximum limiting friction? Anybody can tell? Limiting friction is how much? 10 Newtons. Do you understand it? If I apply exactly 10 Newtons, applied force is exactly 10 Newtons, then which is equals to F limiting. Now also body is said to be in rest or said to be in motion? Everybody.
Said to be in motion.
Said to be in rest, girl. Applied force is equals to limiting friction. So it won't be in move, but it is ready to move. Do you understand, everybody? Clear, everyone? F limiting.
Yes,
if
sir.
applied force is equals to F limiting, body is ready to move, but it is not in actually motion. It wants to move, but it won't move. If I apply 10.1 Newton, 10.2 Newton, then this is greater than F limiting. Then the body will start moving. Actually, it will be moves. Is it okay, guys? Everybody? Clear?
Yes.
Yeah. For example, I know that my body moves only if applied force is greater than 10 Newtons, but I am applying only 5 Newton force. I am applying how many Newton force, everybody? How much? 5 Newton force, but my body can move only the applied force is greater than what? Greater than 10 Newtons. Then the applied force is equals to static friction. Applied force is equals to static friction. Understand, Mari?
Yes, sir.
That is one. Okay, ma? Please note the statement. If I am applying a force, if applied force is less than limiting friction, then applied force is equals to static friction. Okay, guys? Understand, Ra? So if I apply, for example, I'll ask Mr. Kishore. Kishore will apply only F applied is 1 Newton. Then what is the static friction? Anybody can tell? Applied force is 1 Newton. What is the static friction? Static friction is also 1 Newton. I'll say Agalya to apply. Agalya will apply 2 Newton force. Then what is the static friction? Static friction is
2
also
Newton.
2 Newton. So that is why I'm saying static friction is always variable. Understand, Ramari? Clear now?
Yes, sir.
Okay. Static friction is always variable, but limiting friction is maximum static friction. So if any person is exerting the force less than the applied force is less than the limiting friction, we can say body is said to be in rest and applied force is equals to limiting friction. Oh, sorry, static friction. Is it okay, everyone? Please make that statement. Any doubt, Agalya? Shivani? Are you clear, all of you? That is what. If applied force is less than limiting friction, then applied force is equals to static friction. All of you note that point. Okay, Nivedan, Lingesh?
Yes.
Yeah. So that is what. Now let me finish this. Friction in fluids. So we all know that
Can
solid.
you please say the statement again?
Okay, Mari. If applied force is less than the limiting friction, write the statement, everybody. If applied force is less than the limiting friction, then applied force is equals to static friction. Okay, guys? Applied force is equals to static friction. Sam, understand, Sam? Niroshi?
Yes, sir.
Okay. So then, friction in fluids. So we all knows that. Do you think that only solids will exert the friction or fluids also will exert the friction? First of all, I want to give you the definition of fluid. Anybody can tell what do you mean by fluid and examples, please. What is the examples
Sir,
of fluid? If you are not responding when I call,
Friction,
please
no.
don't join from tomorrow. I'm saying you many people, they are simply acting, not all listening and not all doing anything. I'm very particular about it. If you are saying yes or no, understanding or not, only I can proceed further. Otherwise, don't join. I'm very particular. So tell me what is the examples for fluids? Everybody. Hasini is also
Sir,
both
water.
Hasini. I don't know what they are
Water.
doing. So examples of fluids. Can I say liquids and gases? Am I right or wrong?
Yes,
All of
sir.
you?
Yes,
So
sir.
all the liquids and gases we used to call as fluids. So why we can call them as fluids? Anyone?
Because
Sir, they can flow.
Yes, they
The
can flow.
water-
The substances, any substances, they can flow easily. They can flow easily. They are called as fluids. According to me, there is another one. Fluids means no particular shape. No particular shape. And they are not rigid in nature. That is why they can flow easily from one point to another point. So that is what they are called as fluids. So what is the examples of fluids, everybody? Yes, please. Liquids and
Liquid
gases.
and gases.
So
Liquid gases.
fluid also will exert friction on the bodies moving through them. You remember? For example, I will take, this is the liquid. This is the liquid. And this is also the liquid. Now remember, fluids will exert pressure. The object which is passing over the liquid, or the object which is passing through the liquid. This is over the liquid, and this is what, everybody? Through the liquid. Okay, so both the cases, fluids will exert the pressure. If any object is passing over the fluid, will exert the friction. Fluid will exert the friction, or object is passing through the liquid, it will also exert the friction. Do you all understand, everybody? All of you?
Yes, sir.
Please respond. Now, if you are passing over, suppose my surrounding something gas is present. What is that called as? Anybody can tell? My surrounding something is present. What is that called as? Air.
Gas.
So when I'm passing through the air, for example, I am flying in aeroplane. If I am passing through the aeroplane, so definitely I will experience the air friction. Am I right or wrong? Frictional
Yes.
force exerted by air. Am I right? So remember that
Yes, sir.
friction in fluids, if you are passing over, suppose if I take boat is passing over the liquid, then liquid will exert the friction on board. If suppose submarine, if I take submarine will go deeper inside the water, then water will exert friction on submarine. If aeroplane is flying in air will exert a frictional force on the aeroplane. Understanding, everybody? So that is what the friction exerted by fluids we used to call it as drag. What is to call, everybody?
Drag.
Or we can say drag force.